Sigma and pi bonds. In this podcast, we'll extend our discussion of sigma and pi bonds to include hybridization concepts. We'll also identify which orbitals are used to form bonds, and this will include s, p, and various hybrid orbitals. We'll get a better understanding of what this quote-unquote looks like. In other words, visualizing the shapes and the arrangements of the orbitals that are forming the bonds. Please do not even bother with this video or trying to learn this video until you first have hybridization completely understood. I'll caveat this a little bit and say maybe if you only understand how to get the answer, but you at least understand how to get the answer consistently and well, you can probably still do this, but it may still be worth your time to go spend an extra hour or two learning hybridization first, then come back and watch this video. Otherwise, you're just going to be wasting your time. And also make sure you understand the basic discussion of the sigma and pi bonds from the previous videos. Again, if you don't have this down, this video is going to be too advanced and it's just going to be a waste of your time. So it's much better to go back, get those basics, and then try this video. So let's start with the basics. What do these look like? Once we talk about what they look like, then we'll start talking about how to identify them, how to count them, how to get the right answer, but we need to build the basics of what they look like first. Otherwise, it's just going to be memorization. We've already talked about single bonds, and so we're not going to really go into that again. Just as I said in the initial slide here, make sure that you know that video before continuing. So let's start with double bonds. Here I have the basic structure drawn out of C2H4. So let's look at what the Lewis structure for this molecule looks like. Our first step when we're looking at all of this is to look at what orbitals we actually have. And in order to do this, we need to figure out hybridization, which again is why you need to make sure you know hybridization before moving on to this video. Here we have carbon with 3 things that are bonded to it and 1 double bond. So we know that that has to be sp2. If you don't know that that needs to be sp2, go back and review the hybridization video. We look at the next carbon, the same thing, that also has to be sp2. Now, off to the side, I have drawn our sigma bonds. So if we look at our H's first, we know that the only orbital that H has, that has electrons in it that we can use for bonding, are our s orbitals. And so all of our hydrogens are forming our bonds with our s orbitals. Now our carbons, they each have 3 sp2 orbitals and a p orbital. And again, if you don't know how we came up with this, make sure you go back and review the hybridization video. All of the hybrid orbitals are what we're going to use to form our sigma bonds, and it's what I have drawn here. So if we look at any one of these, for instance, the one I have right here, this sigma bond is made up by an overlapping s orbital from the hydrogen and an overlapping hybrid orbital, or sp2 orbital, from the carbon. And we can keep going with that around the molecule. So this actually, because all the bonds are very similar here, it gets a little repetitive. But it's good for examples to do this. So here, we once again have our sigma bond, which is formed by a hydrogen's s orbital overlapping with a carbon's sp2 orbital. And the same thing over here on this side, here, here, and here. Now notice in the middle what happens. Each carbon is forming the sigma bond with an sp2 orbital. This sigma bond, which is still sigma, is formed by an overlap of the sp2 orbitals, 1 from each carbon. Now let's look at what we have left over. We've used up all of our sp2 orbitals. We've used up all of our hydrogen's s orbitals. All we have left are these p orbitals. So what are those going to be used for? These are what we use to form our double bond, or our pi bond. So in order to show you this, I'm going to need to tilt the molecule a little bit at a different angle. We can see that the leftover p orbital is going to be coming perpendicular to the sigma bonds, or at a 90-degree angle to the sigma bonds. And this forms this 2-lobed structure. Now notice, this is 1 pi bond, right? We have 1 sigma bond, and we have 1 pi bond. It just has 2 lobes. And in a minute, we're going to see how this would work if you have a 3rd bond, or if you had a triple bond. That would also be a pi bond. But in this case, we have 1 sigma bond and 1 pi bond. And the pi bond is always formed with the leftover p orbitals. So we've already covered this, but we're going to look at it one more time, just so that we can kind of go through it with actual questions that we're answering, as opposed to me just telling you. So what orbital does hydrogen use to bond with? So think back to our discussion about what all of these were using, and we looked at hydrogen, and we said it only really has an s orbital. And so that's going to bond with its s orbital. And that's true for every hydrogen. Each of these hydrogens are using its s orbital. Now, what orbital does carbon use to bond with the hydrogen? So for this bond, or any of the other bonds like it, what is carbon using to bond with? We know they're single bonds, and if your atom hybridizes, it's going to form its single bond with its hybrid orbitals. So we look at what kind of hybridization it was, and we already discussed that it's sp2, and if you don't know how we figured that out, you're going to go back and review the hybridization videos. And so it's using its sp2 orbitals to bond to the hydrogen with. It uses its hybrid orbitals to form its sigma bond. Now, what does carbon use to form the bond with the other carbon? In this case, they're going to be the same just because our carbons are identical. Once again, I tell you it's the sigma bond, and that tells you that it's going to be the hybrid orbitals. And so we look at our carbons and we say, what are their hybrid orbitals? They're sp2 orbitals, and so it's going to use its sp2 orbital. Again, just walking through what we've already done on the last slide, but doing it by answering questions. What orbital does carbon use to form the bond with the other carbon in the pi bond? So now this is different because it's a pi bond. The pi bonds are always formed by the leftover p orbitals. Now let's do this again, but for triple bonds. So here I have this drawn out a couple of ways. And this first one is just for illustrative purposes. This bottom one is more accurate. It's cartoon, so it's not super accurate, but much more realistic to how things are actually done than this top one. So if we have something like C2H2, and we have a triple bond here, we have 3 bonds, and one is going to be a sigma, and 2 of them are going to be pi bonds. So let's look at what this looks like. Let's walk through the same idea where we say, what does every atom use to bond with? So our first step when we were looking at this sort of thing, when we're trying to understand this sort of thing, is to look at what the hybridization of each carbon is going to be. So we look at this carbon, we say it's bonded to 2 things, and so it's going to be sp hybridized. We look at the other carbon, exact same thing, it's bonded to 2 atoms, and so it's also going to be sp hybridized. Remember, I'm going through that very quickly because you already theoretically know how to do it. If you don't, you're going back and learning how. Now, let's think about what orbitals are left over, just so that we make sure we have a good understanding of what we're doing. For each carbon, we now have 2 sp orbitals, and we only used up 1 p orbital this time, and so each one also has 2 leftover p orbitals. And that's of course true for both atoms. So now, let's look at how these are actually shown in the picture. The sigma bonds are going to be formed the exact same way as what we talked about with the double bonds. They're formed by the hybrid orbitals. So our hydrogens are the same as always. It's going to use its s orbital. Our sigma bonds are going to be formed with our carbons' hybrid orbitals. So we're always forming our sigma bonds with our hybrid orbitals. And I can't really draw it, but the center sigma bond would also be sp. I can draw it in the one for illustrative purposes, just not the more accurate version. Now these leftover p orbitals are going to be used to form the pi bonds. Here I have them drawn out like what they would look like if they just formed the 2-lobed structure, like what we saw in the double bonds. Because sometimes that helps you see how this structure, which is the more accurate one, is actually drawn. So it forms this sort of corn dog-like cloud around the sigma bond. There's still a sigma bond in here, you just can't see it. And that is formed by the leftover p orbitals. And this is what we call our cylindrically symmetrical cloud. And remember from our intro, this is actually rotatable. Now a quick recap. I know we don't normally do these mid-video, but we're going to start going a little bit quicker, so I just want to remind you of really important things to remember. Orbitals overlap with each other to form bonds. When we're talking about valence bond theory, we're overlapping one orbital from each atom. Each atom will have its own, possibly different, hybridization type. If an atom is hybridized, use its hybrid orbitals for the sigma bonds, and use the leftover p orbitals for the pi bonds. So keep that in mind as we walk through our next parts. We're going to walk through one example that's pretty large, and we're going to do it really slowly. This is to give you a really detailed understanding of what's happening. Then we're going to do some faster ones at a speed that would be more expected of what you'd want to be able to do by the time we get to the exam. This one's for slowness and understanding and getting the general principles though. So what type of hybridization is present in CH3, CHO, and what does each atom use to bond with, and where are the lone pairs located? So first off, we're going to draw the Lewis structure. Then we're going to determine our hybridization, and then we're going to think about our answers. That last one, we'll of course do in a bit more detail as we get there. So when we start with our structure, we start by drawing our carbon, and our carbons attached to each other. We know that one is going to have 3 hydrogens. If you need more help with Lewis structures, make sure you go back and do that video. We obviously don't have time to walk through all of how to do Lewis structures here. And you may need to take an extra couple of steps to figure out that there's a double bond here. But if you had just tried to put a single bond, you wouldn't have enough electrons to get everything to have an octet, and so there's a double bond. We always have to draw the Lewis structure before we can do these. So now we can determine our hybridization for each of our atoms and what orbitals are present and available to bond with. Our hydrogens, of course, are unhybridized. This carbon has 4 bonded atoms, no lone pairs, so it's sp3. Review your video on hybridization if you need help with that. This carbon has 3 bonded atoms, no lone pairs, so it's sp2. This oxygen is actually a little bit more complicated. There's a couple of options. You can say that it's unhybridized, or you can say that it's sp2 based on the number of lone pairs and the 1 bonded atom. Either is correct. So now let's look at what this looked like. Of course, eventually you're going to want to be able to do this on your own, but for the first example, I just want to show you in what it looks like based on the pictures similar to the last ones. So I have 2 different angles here so that you can see them. It's the exact same molecule. One is just rotated a few degrees. I've also labeled your carbons so that we can keep them separate. So this is your X, this is your Y. So let's start with hydrogens because it's the simplest. It's all the same, and it's all the same as the last one. These are your hydrogens, and your hydrogens only have 1 orbital that has electrons in it. Right? If we draw our electron energy level diagram for hydrogen, you just have your 1s orbital with 1 electron in it. And because of that, this is the only thing you can use to bond with. So just like before, your hydrogens use their s orbital. Now, what about the carbon that we've labeled X? If we look at the carbon that we've labeled X, think back to what we did on the last slide. We know what our hybridization for these are. We know that this carbon was sp3 and this carbon was sp2. And we know that our sigma bonds are always formed with our hybrid orbitals. And so if we look at our carbon that we have labeled X, we know that all of the s and all of the p orbitals are gone now, and we've turned them into sp3 orbitals. And all these orbitals are now called sp3. And that's what it's using to bond to each hydrogen with. Now let's look at the other carbon. The other carbon is sp2. And I ask you, what does the carbon use to bond to the other carbon? Since we know that all of our sigma bonds are formed with our hybrid orbitals, we can fill these in. Maybe this one's a little bit easier to see. our carbon is going to bond to our other carbon with sp2. So let's look at this bond for just a moment. That's actually formed by one carbon's sp3 overlapping with another carbon's sp2. And this is the first time in this video that I've shown you these overlapping bonds where we're overlapping two different hybrid orbitals, but it's not any different than the other ones that we did. Let's look at one more. What orbital does carbon use to bond with in the oxygen pi bond? So I already showed you what the carbon uses to bond to the oxygen with as far as the sigma bond goes. It uses this hybrid orbital. So now I'm asking you, what does it use to form the pi bond? First, let's label the pi bond here. This giant pink two-lobed structure is our pi bond. And we know that our pi bonds are always going to be formed by our p orbitals. And we know that this carbon can do it because it's sp2 hybridized, which means that it has one extra p orbital. And so the leftover p orbital forms the pi bond. Now let's do a much faster example. It's actually way bigger, but we're not going to walk through the entire thing, just pieces of it. And this will show you a little bit how I'll ask this on exams and homework and things of that sort. So first off, how many sigma bonds are present? When we go to count sigma bonds, we're counting the first bond of any double bond or triple bond and any connected bonds. So let's walk through this one at a time. So first off, 1, 2, don't forget there's a bond between the oxygen and hydrogen. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and now watch out because that carbon, this one a lot of people tend to forget, this carbon and hydrogens have 3. So we have to count that as 3, which gives us a total of 17. Okay, now how many pi bonds? The pi bonds are the second and third bond in a double or triple bond. So this one's a little bit easier. We go through all of the areas where there's a double bond, and we count it as 1. We don't have any triple bonds here, otherwise those would be counted as 2. So 1, 2, 3, 4, 5. So we have 5. That's super quick, and it's a way for me to just test whether you know, 1, what condensed structures or line structures look like, 2, if you know how to count sigma bonds versus pi bonds. So now let's do another example where we look at the circled atoms. So in this case, I've circled 2 of them, and we talk about what they use to bond with. So question, what is the circled carbon used for each bond? So notice this is a big structure, but that's okay, it doesn't matter, because all we care about is the carbon. So first step is to figure out its hybridization. And it's bonded to 3 things. It's bonded to 3 things. And so it has no lone pairs, so it's sp2 hybridized. So we may want to think about what that means for what orbitals it has. So if we think about the carbon, it's sp2 hybridized, and so it has 3 sp2 orbitals and also a p orbital. Again, if you don't know how to do this, please go back and watch those hybrid orbital videos so that you know how to do this. Otherwise, it's not going to make a lot of sense to you. All right. We know that sigma bonds are formed by the hybrid orbitals. So all of your sigma bonds are going to be formed by your sp2 orbitals. So we would have an orbital coming off this way, an orbital coming off this way, an orbital coming off this way. And those 3 orbitals form your sigma bonds. Now, what about the other bond? What about the double bond here? What is that formed with? That's always formed with your leftover p orbital. And so if we have our leftover p orbital here, that's going to come across and combine with the oxygens to form your pi bond. So we can do this for just one atom in the molecule as well. We don't have to actually walk through the entire thing. Of course we could, it just would take a lot of time. And if you come to office hours, we tend to do a lot of this. So if you're having trouble with this, keep in mind office hours are a great place to come and get help. And we do probably 4 or 5 of these really big molecules straight through. Same thing as for the carbon. For the bonds, what does the oxygen use? But I ask you one other thing, and I say, what does the lone pairs go? So remember that we have two sets of lone pairs here that we don't draw in because it's a line structure, but we should still know they're there, and we should be able to say where are the lone pairs. And we haven't really talked about this yet, so I thought I'd take this moment to do it. So first off, we start the same way as before. What's our hybridization on our oxygen? We know that we count lone pairs and bonded atoms, and so we have 1, 2, 3, 4, which gives sp3. So our hybridization is going to be sp3. Now that makes things a little bit simpler because we know that we've used up all of our s orbitals and all of our p orbitals, and so we simply have 4 sp3 orbitals. So now, when we go to look at this and we say, what is the oxygen using to bond with? It's actually just using all of its hybrid orbitals, since it only has hybrid orbitals. The s and the p orbitals are all gone now, and they're turned into sp3 hybrid orbitals. But what does that mean about the lone pair? And that's something new. So our lone pairs are also going to go in our hybrid orbitals. And if it helps you remember it, think about how we decided on the hybrid orbitals to begin with. We counted bonded atoms, or in other words, we counted sigma bonds. We originally called them quote-unquote bonded atoms, but now we know what we're really counting is sigma bonds. And we counted lone pairs. And that's what we use our hybrid orbitals for, is our sigma bonds and our lone pairs. And so all of our sigma bonds are formed with our sp3 hybrid orbitals, and all of our lone pairs are also in sp3 hybrid orbitals. And we could do this for every other atom here, but we're going to stop there. So for good practice, go through and do this for all of your other atoms, and decide what orbitals each atom is using to bond with for practice. And if you want, and you're a good drawer, you can even draw them in, but at least be able to name them. So in summary, we took our discussion of sigma and pi bonds, and we included hybridization now. We identified which orbitals are used to form bonds, and have a better understanding of what this looks like. The best way to check if you really understand what it looks like is to actually try to draw it out. You should at least be able to picture in your head what they look like. To practice this, you really can just find any molecules, really any molecules at all. Organic molecules are a good example of walking through these. And do what we did for the first two examples. Try to picture what's happening in all the orbitals, trying to draw them if you can, or just imagine them if you can't. And think about what each bond is being formed with from each atom. Generally, I will just ask you to name them. I don't generally ask you to draw them. However, being able to know what they look like is the best way of being able to understand it and preventing yourself from making mistakes.